hypothesis test for proportion, home team wins. Or home team advantage. So let's say the teams, we expect teams to be equally matched. So there's a 50% chance one team wins over the other. If there's a home team advantage, then we think it's more likely the home team did. Agreed? That makes sense? That's what home team advantage means. So if we think there is such a thing at a home team advantage, then that means we think P, the proportion of home team wins, should be greater than 50%. That's what I believe a home team advantage means. You have a better chance than even of winning the game because you're at home. What does P mean? P is the proportion of home team wins. And the data we have is related to soccer. So let's say this is for soccer. I have a hypothesis there. Is that hypothesis going to be a null or an alternative hypothesis?
No.
Try again. Alternative? Yeah, it's going to be an alternative because it's got a greater than in it. Yeah, so alternative hypothesis is either going to be a not equal, a greater than, or a less than. That's how we tell if it's an alternative. One of those three symbols in it. So that is an alternative. And the typical null is just going to be equals. So we're going to say if there isn't a home team advantage, then the proportion of home team wins, it shouldn't matter. It should be 50% also, 0.5. So that would be my null hypothesis, H0. And my alternative hypothesis is that, well, you know, some people believe that the home team has an advantage, which means the proportion should be bigger than 50%. Typical significance level is 5%. Okay, so step one, define your parameter, come up with your hypotheses. Step two is get the data, go to STAT243. So over to STAT243. STAT243 happens to have this data in there. The first step, make sure you have the right data set. So I'm on soccer home wins. The data in STAT243 comes with a null hypothesis. If we're bringing our own data in, we have to set that. Common mistake people make when they're doing hypothesis tests here is forgetting to set the null hypothesis. So make sure we set that. Here it was given. Once I have those two, then I just generate. And then I have to decide which test this is. So according to the alternative, is this going to be a left, right, or two-tail test? Right tail. Because the greater is to the right. Okay, so the alternative always tells us which test to pick, left, two, or right. So then I'm making progress. Data's in there, null set, I've generated. Next, I pick my test. Okay, there's another step I got to do. What's the next step? Anybody remember? Sample statistic. Right, plug in the sample statistic. So that's given over here. So my sample statistic is 0.583. So I go down to the bottom and I replace that number with 0.583. Right, sample proportion. And what's this number up here? P-value. It's the p-value, right, Ian? Yes, that's the p-value. Okay, so I'm going to make a quick sketch of this. So according to STAT243, let's use a different color. The null hypothesis is that home team should win 50% of the time. There's no advantage. We have sample data. So this is my mu here. We have sample data over here, 0.583. That's my X bar. And based on that, STAT243 said that this group of samples to the right there, that's the p-value. STAT243 put it at what? 0.43. What's it again? Yeah, right there, 0.043. Okay, so the next thing is, how does that compare to my significance level? So once I get that set up, then I compare the p-value to the significance level. So my p-value is 0.043, or you could say it's 4.3%. My significance level, we went with the standard, which was 0.05 or 5%. And the p-value is smaller. If the p-value is smaller, then the decision is reject the null. If you reject the null, then your conclusion means the evidence supports the alternative. And then we try to restate what that means in terms of our parameter. So I would look back, what is my parameter? Proportion of home team wins for soccer games. The alternative, that proportion is higher than 50%, meaning they have an advantage. Okay. So my conclusion would look something like this. We have sufficient evidence. That state the parameter. Proportion home team wins. For a soccer team. And we state the proportion in the context of the alternative hypothesis, which is that proportion is greater than 50%. So the proportion of home team wins for a soccer team is more than 50%. Right? That implies there's a home team advantage. Evidence. Again, what a hypothesis does is it measures the sample, compares the sample to some other belief about the population and says, is there a difference or not? And if there is a significant difference, we have evidence to support it. If there isn't, question?
On the bell chart, would it not be 2.5% on this side and 5%? It's not.
Here?
Yeah, because it wouldn't, the 5% on the side mean it's a 90% confidence?
No, so we're not doing a confidence interval. So that's different. So all we're doing is saying, we're trying to figure out what is the probability that these two numbers could be farther apart. And what we found is the probability they could be farther apart is about 4%. About 4% of the time, given similar kinds of data, we'll find it will be more than that. And the other 96-ish% of the time, it'll be less than that, right? And that, the idea of the 5% here is our cutoff to say, is the sample far enough away from what the null says? And in this case, it is far enough away. And again, this takes a lot of getting used to. It's a little more complicated than confidence intervals. And we just got to keep doing them to try and get used to them. So that's our goal. We have to get used to how to determine which hypothesis is which, and we have to decide which test to make, and then we have to decide what is the p-value test. Yeah. And then how do we describe that to my model? It's a lot. All right, more of this next class. Start reading the book if you haven't already. See you soon.